On the last video, I mentioned being able to track the VFO oscillator with the RF front end so they stay synchronized. So the RF amp is always tuned to the frequency you want to receive before it gets processed by the mixers, the two mixers in the dual conversion set. Now, in the frame here is a passive band pass filter. Now, a band pass filter allows a certain range of frequencies to pass. They call it a band. Now, this unit here is tuned for 80 meter ham band, which let's just say it's 3.5 to 3.8 megahertz. Now, you could also include 75 meter in there, so you'd make it 3.5 to 4 megahertz. I keep saying megacycles because I'm old. So what I did differently, now you can go, Kits and Parts has a schematic. Basically, this is what it's going to look like. It didn't print out that well. These are toroid coils, and they're T50-2s. They're red. They have 30 turns and then 6 turns. The 6 turns is where the signal comes in. On this one, goes in, it resonates. Then it gets fed by a capacitor over to this one, which resonates, and then it goes out through another capacitor, and then out through another winding and out. And you can see the waveform on the scope. Now, if I go slightly above, right now I got it set for 3.6 megahertz. And if I tune it, as I tune it up, notice it doesn't let only the 3.5 to 3.8 will go through this. Okay, that's what it's for. It's a band pass filter. So you would need a circuit board for each band, and that's what you'll see on a lot of the newer radios right after the tube era. They started making transistor sets. They didn't want all those tuning capacitors and those pistons, those ferrite pistons that go in and out of coils. There's a lot of mechanics involved, so they decided to, let's just put a circuit board in there for each band and make it a band pass, and then we switch between those for whatever band we're on. Now, what makes my circuit board different, okay, and I say okay a lot, and I notice a lot of other people do also. All right, let me go up to 4 megacycles, and let me retune my band pass filter. Notice I can retune my band pass filter, and if I go above or below, it drops down. There's 4. And you say, how is that possible? Well, there's 3 varactors. Instead of using a fixed capacitor for the band pass filter, for experimentation and working with the circuits that I work with, I decided to wire this band pass filter up with varactors so I can change the frequency range. And that's what got me into, well, let me make it track the VFO. And then I got fancy and I said, let me make an RF amplifier that works like a Collins. And then you realize that the mechanics to do what they did in the old days, modernized, has just as much work to it. So what they did, remember that Radiocraft schematic I talked about? It's one of my videos, you look, it shows Radiocraft. And in there is a schematic for a shortwave radio. Actually, it's a ham radio. And they use band pass filter. And you make a band pass filter for each ham band. And my favorite ham band at night is probably more like 75 meters. And the guys were on last night. They used to be on during COVID all the time. I throw them on. Some of them are my age and a little older. But anyway, I'll put them on at night. And those bands work better at night than during the day. And 65% are 6 megacycles at night, or megahertz. You can find different stations in there. Maybe WCCR, Cuba's down in there. And that's what I was making all my circuits, because at night when I'm working on the circuits, I'm able to tune the frequencies and test the radio out, because those are the frequencies that are being used. But I just want to show you, this is passive. There's no amplification. Now you'll say, what's that battery over there? Well, that battery supplies the 9 volts, which goes to the trim pot, or to the pot, which then allows me to dial the frequency. So in other words, I can put this in a radio and then have it set like at a certain point for the band. And then as I'm receiving the signal, I can touch that pot up and make the signal actually get stronger. I'm moving the tuned circuit towards the signal. Instead of being bandpass, I move it closer to the frequency. Because you notice as you change the frequency, the signal level drops off. So you have to use a bandpass filter for only a small range of frequencies. And if you go look at the old Collins, they did the same thing, but each band pass filter tunes along with the VFO to get maximum amount of signal. And that's why those radios, the R390, is still an incredible radio. And yes, it won't do like digital communications and things like that. But in its day, and even to this day, that's the radio that in mint condition it goes for $1,000. And there's a lot of radios that have been made since the day that thing was made that nobody wants. And they have bandpass filters in it that are stationary. And I just wanted to show you, you know, I built this, this board has to be 8 years old. And I got into varactors, and these are ones that are like 360 picofarad varactors. They really let me go up and down in frequency for experiments. And this is my board, and you saw I showed you my other board that has a 1 transistor amplifier in it. And that's how I build and how I think. And I have modules. And setting this up was really a pain in the ass. I want to tell you right now. I have my HP up here. Let me go for my HP. Here's my HP frequency counter up on top. And we'll go back down. And getting this all set up, the plugs in, getting the scope probes to actually make connections. What was the one thing? Oh, one of my sockets on my multi-plug for the 110 is a little wonky, so I had the LED light in it, and it started flickering. And I'm like, oh, what now? But to set this up, just to show you that you can use toroid coils, and like I said, they're T52-2s, 30 turns, 6 turns as the input off the antenna, and then from this coil to this coil is probably about a 10 picofarad. There's actually a website to actually put in the values and see what frequency it'll be at. And it's a bandpass filter website, and they have the math. You put in your parameters, and it'll tell you what your bandpass will be. And you can build a bandpass filter without any variable capacitors. If you can get the close values and put it in there and the right amount of turns on the toroid, yes. But I said to myself, let me make the thing variable. And then I got fancy. I said, let me add an amplifier to it. And then I got even fancier. Let me use the exact setup that the Collins 388. And I said, let me do that. And that is a certain coil, tune coil off the antenna, but then the next, and into an amplifier, and I used the transistor, and then these two on the Collins are bandpass setup. You have a capacitor that hooks them together, the signal together. It's really interesting stuff. You could spend weeks just working on an RF front end, and that's all that RF front end does. It tracks the signal. As you're tuning the knob on the VFO, the RF amp, if it's a good radio, is following along with it, and it's eliminating signals above and below what you're listening to from coming through. So if something's on a second harmonic, or second harmonic, or double the frequency, it really helps to prevent it from coming through. That's why SDR radios are such crap. They have one little coil in there, and that because they're just selling you something to, it gets this frequency, it gets that frequency. Look, it's got this waterfall display. Yeah, it's lipstick on a pig. That waterfall display is lipstick on a pig. I think that's it. All right, that's it.